Good afternoon. This is my first official video regarding mathematics, O levels, chapter 1, D1, and the topic will be number. Let's revisit the previous concept which we did in our introductory video. We did numbers, whether the number is prime or composite. Right? So when we need to check whether the number is prime or composite, the first thing to check is whether the number is again even or odd. And I hope that you remember that even numbers are those which are divisible by 2, odd numbers are those which are not divisible by 2. Okay? So this was a very short revisit to what we did earlier in the introductory video. Okay. Now, if I look at the chapter of D1 exercise 1A basic level, there they wanted us to know or check or determine whether the number is a prime number or composite number. Let me just add one thing here, since it wasn't very clear in the last one, that 1 is a number which cannot be added in prime nor can be added in composite. Why? You need to remember that 1 is a factor of all the numbers, right? It comes in every table. So we don't consider it prime nor we consider it a composite number. Okay? So whenever we have a number and we need to check whether the number is prime or a composite number, for example, exercise 1A, question number 1, part A is 87, and we need to see whether the number is composite or prime, there are 2 tips to check it. Number 1, the very first step, we see, is it divisible by the first prime number, which is 2? If no, moving on to the second prime number 3, and we see whether it is divisible by the second prime number or not. Now, it seems little difficult to actually divide a 2-digit or 3-digit number directly with 3. So how we do it? It's a very, very simple way. We simply take both the digits, add them. 8 plus 7 is equals to 15. And we all know that 15 is divisible by 3. So this is how we check it. We simply add the digits of that main number and we see if the sum or the total of that number is divisible by 3, means the main number will be divisible by 3 as well. So 3 is divisible by 15, means this 87 is a composite number. Okay? I hope it's clear. Now, let me move on to the second part of it, B part of it, which is 67. If you have D1 with you, you can open it and you can, do it right along so that you can practice it. And if there will be any query, you can simply add in the comment when I upload this video. Okay. So 67, again, we see whether it is divisible by 2 or not. And very simple way to check whether the number is even or odd is you check the last digit. If it's it's not 2, 4, 6, 8, 0, it means it's an odd number. So it's 7 means it's not an even number, mean it cannot be divided by 2. So we move on to the second factor, second prime number 3. 6 plus 7 is equals to 13, and that's a common sense thing. We know that 13 only comes in its own own table when we multiply it with 1, and it never comes in any of the tables, so it's a prime number. Okay? Now, part C. We have 73. Again, 3 is an odd number, means cannot be divided by 2. Moving on to 3. 7 plus 3 is equals to 10. Cannot be divided by 3. Mean it's a prime number. Okay, it's a prime number. Then last part of it, question number 1. Since it's these are the starting videos, so I will try to be doing it in detail so that you can actually get an idea how to solve it, and you will understand each and every simple bit of it. So we have 91. As I said, 1 is not a prime number. So what we can do is, we simply check by adding these two numbers. 10 divided by first prime number 2, yes, so it's a composite number. We only do this 2 wala division when we have 1 in the end, okay, since it's not a prime number. Okay, so it's a composite number. That was all about prime and composite numbers and how to determine them. Now the second thing is, which I will be telling you, is prime factorization. Okay, how to do prime factorization? This prime shows that we will be using prime numbers, and normally, as a common sense, we need to understand that maximum will go till 11 normally when we need to factorize a number. Okay, remember that. That's tip number 3. That whenever we need to do the factorization, prime factorization, we need to think about maximum till 11. Normally, this is what we require to divide a number. Okay, so how to do the prime factorization. And also in question number 2, in fact 1A, exercise 1A, question number 2, they said find the prime factorization of each of the following numbers, leaving your answer in index notation. Index notation, what is index notation? First I'll explain it to you so that when I'll solve the question you will know how and why am I doing those steps. Okay, index notation is that if I'll divide a number or find the factors, if 2 is coming 2 times, then I can write it 2 times. Okay, if 3 is coming 3 times, I can write 3. Okay, instead of writing it this way, if I'll write it this way, this is index notation. I hope it's clear. Okay, so let's start. Question number 2, it's 72. So I need to find the prime factorization of this number. Okay, and with this prime factorization, how will I do it? Simple thing, the way we normally take LCM most of the time. Okay, we'll take this 72 here, and since the last number is 2, so we'll go with 2. 2 3s are 6, 1 will move here, 2 6 are 12. Alright, then 2 1s are 2, 1 move here, 2 8s are 16. Then 2 9s are 18. Then 3, because 2 cannot go there and second prime number is 3, 3 3s are 9, and then 3 1s are 3. So what do we get? We get 2 into 2 into 2 into 3 into 3 is equals to 72. And we can write it 2 cube into 3 square is equals to 72. Okay, so this 2 3 into 3 2 is the answer. Got it? If it's not clear, let's do the next one and you will understand it. Number 2 is 187. Okay. So let's start it. 187. Since the last number is odd, it's very clear that it cannot be divided by 2. So we'll start with 3. 3 Since 3 cannot be divided, so we'll check 5. Even 5 cannot be, 5 is not going to be divisible since the number is 7. It's not 5, it's not 0. We'll go with 7. 7 does not have 18 in it. We move on to 11. So 11 can be the answer here. So we'll check. 11. 1s are 11. And we'll move 7 over here. Right? So it will become 77. So 11, 7 is equals to 77. Okay. Now 17 is a prime number and we know it. As I said, it's a very rare situation where we move on to the next numbers other than the prime numbers till 11. So here we have 17. So simply we'll directly be multiplying it with 17. Okay. So 17 ones are 17. So the factors or the prime factorization will have the factors 11 into 17 as an answer for 187. Alright? It's not very difficult. It's very easy. Just remember the first 7 to 8 prime numbers and you will know how to do the prime factorization. Okay? Now moving on to part C of question number 2. That is 336. Okay. So let's start it. I'm enjoying it. I don't know about you guys. But anyway. 336. Since the last number is even. Right. The last number is even. So we'll start with 2. 2 1s are 2. 2 6s are 12. 2 9s are 8s are 16. Okay. So again we have even number. So we go with 2 again. 2 8s are 16. 2 4s are 8. Okay. And then we have 2 4s are 8. 2 2s are 4. That's a cute one. 2 2s are 4. 2 1s are 2. Here comes the end of 2 and moving on to 3. Right. So I'll just make one over here. 21. So 3 7s are 21. And then 7, simple, 7 1s are 7. So we'll have, I hope now you understand the index notation of it. So I'm just going to be directly writing it into index notation. I can write 2 4 or I can write 2 2 into 2 2 into 3 into 7. That's the answer of it. So this was question number 2C. So I will not be doing question number 2D. It's quite easy. The number is 630. So I'm leaving it on you now. Okay. Now, if we have a square root or a cube root, this is called a square root. What is a square? That's the second topic. And what is a cube? Okay. I'm explaining every simple simple step and a basic of it, so that once we will be on the same page of understanding these little small things, then it will be easier for us to move on to the next little advanced levels of numbers and then later further other questions. Okay, so initially I am explaining every thing. I'm trying to explain it in a simple way, but I'm touching every bit of it. Okay, so what is a square and what is a cube? Though you already know, you might know about it, but for them, for the people who don't know about what is a cube, what is a square, let me explain. If we multiply one number with itself twice, it makes a square, means twice same number. It does not mean if I write 3 square, it does not mean 3 into 2. Please don't. Means 3 will be multiplied to itself. 3 square means 3 will be multiplied to itself once more. 3 will come twice, means 9. Okay? Similarly, if I'll write 4 square, it means 4 into 4, which is 16. So I'll be writing few squares for you, and I would request you to please memorize them, because most of the time if you have the square number in your mind, it's easier to solve the question. 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100, 11 square is 121, 12 square is 144, and so on and so forth. Okay? So you need to remember these squares. Okay? So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I remember till 20. So I would request you to remember till 20. Okay, 20 के square तक आपको आना चाहिए आपके tips के ऊपर. Now moving on to cubes. What is a cube? Cube means 3 times. Okay. So if I'll write 2 cube, that means 2 will be multiplied to itself 3 times, means 2 2s are 4, 4 2s are 8. Okay, so cube of 2 is 8. Fine. If I'll write 3 cube, then 3 3 3 means 3 3s are 9, 9 3s are 27. So cube of 3 is 27. So the way you actually need to remember squares of numbers, similarly you need to memorize the cubes of numbers too. So it's gonna make it easier for you. Okay, so this was about cubes and squares. When we make this shape, this is called square root. If I'll write 3 here, it will become cube root. Okay, if I'll remove this, then it simply is a square root. Okay, this symbol is actually 1 3 or 1 2. When let me explain. If I'll write this of 4, it is actually 4 power 1 by 2. These things are equal. Okay, so this square root means power of something is half, 1 by 2. Okay, so if I write cube root, it means power of a number is 1 by 3. Exponent is 1 by 3. Okay, These are simple common concepts which you need to keep in your mind. Okay, fine. So now question number 3, we're moving on to question number 3. Don't forget that we were doing our prime factorization, and now they have given us the prime factorization in exercise 1A question number 3 in the form of a square root and a cube root. I told you already what is cube root and what is square root and why we need to memorize them and why we need to remember them. It will be explained in this question. So this is 1764. Again, question number 3, exercise 1A, book D1. How are we going to solve it now? They want us to do the prime factorization of the following number. Again, same process. We'll just take this number. It's an even number. So we'll start with 2. 1, 7, 6, 4, 2. 8s are 16. 8s are 16. 2s are 4. I hope you know the tables. At this age you must. 4s are 8, 4s are 8, 1. Okay. Now we check with 3. 3 1s are 3. 3 4s are 12. 3 7s are 21. 7. 2s are 14. 1 is a 7. Okay. I'm doing it here. 21. 7 3. We can even do this with 3, by the way. And 3 1s are 3. Okay. Fine. So how many 2s we have? 2. How many 3s we have? 2. How many 7s we have? 2. It means we have 2 into 2 into 3 into 3 into 7 into 7 is equals to, what was the number? 1764. 1764. Okay. So 1764 is equals to this. 2 square, 3 square, 7 square. Can I write it this way? Yes. I told you this means power 1 by 2. Means when I open this, 2 square, 3 square and 7 square, they all will be cancelled with this 1 by 2 thing, and we'll have 2 into 3 into 7 as answer of prime factorization under root 1764. Clear? If there will be any confusion, you can rewatch the video and then you can ask me the question. Alright? Now I'll solve question number C. Question number 3, part C. I'm leaving question number B part, question number 3, part B for you, and I will be leaving question number 3, part D for you. So I'm solving C now. Question number 3, part C, exercise 1A, book D1. Cube root of 3, 3, 7, 5. Now, it's a cube root, means the power is 1 by 3. Okay? So let me solve it. 3, 3, 7, 5. Last number is 5. We can start with 5. We can start with 3. It's better to start with 3. It cannot go on 2. So we'll have 3 1s are 3, 3 1s are 3, 3 2s are 6, and 3 5s are 15. Again on 3, 3 3s are 9, 3 7s are 21, and 3 5s are 15. you need to know the tables. 3 1s are 3, 3 2s are 6, 3 5s are 15. Now it's not divisible by 3. Okay, so next prime number 5. 5 2s are 10, 5 5s are 25. 5 are, let me write it here, 25. 5 5s are 25 and 5 are 5. So how many times we have 3s and how many times we have 5s? We have 3 3s, we have 3 5s for the number. Okay, 3 3 7 5. So it means 3 3 7 5 cube root is equals to 3 into 3 into 3 into 5 into 5 into 5. Right? This is what we did. If you could see, 1 2 3 1 2 3. So we have 3 times 5. It was here. I did it here. So 3 times 5. Okay. So now 3 times 5 means, can I write it like this? Which means this and this 3 will be cut with this cube because it's 1 by 3. And we have 3 into 5 as the factor, prime factors of cube root of 3375. You can check the answers at the back of the book later. Just to confirm, if you don't understand anything, please do ask me in the comment box of the video, alright, so that I will be clearing it up. So that was question number 3. I'm leaving question number 3B for you, and I'm leaving question number 3D for you. So you need to practice it there. Now I will be moving on to question number 4 for the prime factors. Question number 4 is, given that the prime factorization of 9801 is 9801 is 3 power 4 into 11 power 2. This is what is given in the question. Now they said find under root of 9801 without using a calculator. That's the condition they have given in question number 4. It's very easy since they already told us that this thing is equals to these factors, right? So what we simply do, we will put these given factors in the under root because this thing is equals to this. So we'll write 3 4 into 11 2. Okay, and we already know if there is no power on the under root, it automatically means the power is 1 by 2 of this under root. Okay, it means that 3 power 4 into 11 power 2 is equals to this 1 by 2 is the value of 2. So we will cancel these out and we'll have 3 power 2 into 11 as prime factors of 9801. Okay, it's very simple. The question is given in the book, exercise 1A, question number 4, book D1. Now I'm leaving question number 5 on you. I think today we will be doing till question number 5 so that I can see the response. That if you don't understand anything, you will be getting back to me, and then we'll be moving on to question number 6 to 12 tomorrow or maybe tonight. Once I'll see the reaction or the comments that whether you understood the concept or not. Okay, I hope the thing was easy for you. I hope you understood each and every concept. I'm doing it thoroughly, reason being these are the initial and the starting videos, and secondly I would like you to understand it completely, so that once we will be doing complex questions, you will have clear concepts with you already. Okay, thank you so much. I hope you will like it. If there is any mistake, please just ignore it or comment or let me know where I need to correct it. Thank you so much. Take care. Allah Hafiz.